Okay, if there's 28 in between, how are we gonna come up with exactly,
Yeah, just estimate it.
okay, estimate it?
So we don't have to subtract for both, like how you did over there?
Well, this one's kinda nice because it was
Yeah.
smack dab in
The
middle.
So we'll just put 0.85.
We can put 845, but if we do 845,
80%, right?
Yes, I said the 80th percentile.
That would be 8.2.
I'm gonna go 842.
0.83.
I'm
Yeah,
gonna go with
3.
842, because if I divide it into 5, or divide by
No,
5.
because this is 8 and that's 5, so 0.85.
7995.
Yeah,
You did 80 already? Wait, what?
No, yeah, 7995 is closer, but,
I just put.
do we have to?
So if I'm looking at this,
80%, right?
right there,
Right.
can I write on that? Okay.
can I just take the 0.84?
Is
So the
0.85.
Yeah, that's what I just said.
Right. And then if I look at this one,
Mhm.
right below it, is 0.84.
Right.
Right?
And I want 0.80.
I don't know, right.
So which one looks closer?
0.7995.
Oh, I can just pick
Yeah,
it?
so you can use that, or you can estimate it a little bit
Oh,
higher.
I'll use that.
Use it, yeah.
I'll just use that.
The 0.842 is not a bad estimate, I mean, because it is just a touch.
Yeah.
Like you said, if you divide that, there's how many between? There's what
Like
between?
28.
28?
So I would have divided that by 5, actually. I would have probably, just to do the both sides, to keep it on an even number instead
Yeah.
of a really funky number.
Yeah, normally the only time, if it's real close to being smack dab in the middle, I will go to the 0.5.
Oh, okay,
But if it's not smack dab in the middle,
Just
I
take
tend
the
to go to
closest.
the closer end.
okay, got
So
it.
I would use 0.84.
okay.
I see nothing being written,
Because I
Megan.
have 0 idea.
Well, where's your Z table?
Right here.
Okay. Where do you find 80% in your Z table? Highlight the 80%.
Here.
No, that's 0.8. That's
I don't see
the
any.
Z score.
I don't see any 8.
Huh?
They only look at 3.4.
Yeah, because see, you're looking at the Z scores. When remember what did we do once we found a Z score, we looked where?
Oh, here.
Which gave you the probability, right? So if I'm giving you the probability, the 80th percentile, you gotta be looking in the body.
So,
Yeah, so what Z score does that refer to?
I use this one.
0 point,
It is closer to 0.8.
and if I look down below, so see, this is where I gotta sort of estimate. So see, here's where you have no paper, so it makes it hard to do. You cannot do these without writing things down. So if I look at that, you sat there and you found 0.8023,
What did you put for your explanation? Did you put 80% is?
which I can think of that as
80% of reviews are
80.23%.
less than
Right.
4.25
And that was at 0.85. This is the Z score.
1.2 divided by the square root.
And then if I step down from that, I get
8.4. I mean, 0. Yeah.
0.7995,
1.2
which is about 79.95%, and that was 0.84.
Actually,
And I want 80%.
What did you get? Abby?
Oh, I didn't get it yet.
So which of these is closest to that?
1.252.
4.23955?
Looking for
What'd you get, Rachel?
is that's the z-score I'm probably going to use.
Am I doing it wrong?
See, the
0.23955?
probability, I wanted the 80th percentile, so I gotta find the 80th
Oh, wait,
80%
4.2.
in the body,
Oh,
and then find the z-score that was
Okay.
attached to it.
the,
We had been calculating the z-score, right?
Mhm.
And then
Sure,
finding
the
the
z-score.
probability. We're
Seven
doing
point-
it backwards now. I'm giving you the
7.95.
probability, the
What?
80th
Nope. What is it?
percentile.
Oh,
And we
I
have to
use those.
find the associated
are we
z.
using that?
Oh.
I thought we used
Okay,
that.
I thought we were doing
No?
all that other stuff.
No, no.
I didn't like.
Oh, I see, I see.
Well,
This-
you need to do all
this
that
is the same thing
before
as
you
that.
can do this.
Is it?
Because that is
Okay.
a probability. This is the actual
So for
z-score.
me to do this,
Oh, that's it.
the first
Okay,
thing I
okay,
gotta
okay.
remember
Thank you.
is the mean of my population was 4, which meant that the mean of our sample size is 4. The standard deviation of my population was
1.2.
what?
1.2.
1.2. Which means the standard deviation of my sample size is,
1.3.
no,
Oh, what?
0.3.
what's the relationship between this and this?
Oh,
Equals.
the sample size.
Sample
Yeah.
error.
It's 1.2
Oh, yeah.
divided by
Square root
square root
of
of
And
n, which is 16 in this particular problem. So see, I need to use all this information. If I want the 80th percentile, I have to find the z-score for the 80th percentile. Now again, most of the time when we start doing these, we're not going to find the exact value that we want. So we're going to have to make some adjustments. So we found that 8023, which is the 80.23 percentile, was with the z-score 0.85. And we found that 0.7995, which is 79.95%, was 0.84. So the number we want is probably just a touch above 0.84. So if you wanted to use 0.841, that would be fine. If you wanted to use 0.842, might be a little higher, I don't know without doing it, okay? Since this is only 5/100ths away and this is 23/100ths away, this might be good enough to use, okay? So you're gonna have to look it up and see if it's good enough to use. Now, normally my rule of thumb, here, the number we wanted was smack dab in the middle. I am either going to use the low score, the high score, or the one that's smack dab in the middle, depending on where I'm closest to. So see, had this number been, so I'm going to make an estimate. I gotta make a judgment call on this. And everybody's gonna make a little bit different of a judgment call. So if you use 0.84, you're probably good. If you use 0.841, you're still good. If you use 0.845, you're probably a little high. Because that is more than, this is fairly close, right? 80% is real close to here. So I have to pay attention. I've got to look at my numbers and see how they're spread out and make a judgment. if we're using technology, they will actually look it up and give me an exact value. So sometimes we can do that. Sometimes when I do my answer keys, I use electronics to do it, and they might actually, they'll use a little bit different value here. So you gotta be careful. So if our numbers come up slightly different, you gotta be aware of it. So we now have all the information we need to be able to try it. We want to find out the time that I'm longer than this, shorter than this 80% of the time, I'm longer than this 20% of the time. So what we now know is that the z-score that we want is 0.84. We're going backwards. So I know if I'm looking at this, remember we always have a z-score. The z-score is always found the same way. Okay, I'm just going to leave that off for a second. It's always found the same way. I'm going to take some number, subtract a mean, and divide it by a standard deviation. In this particular case, I'm talking about my sample, right? So that means I want to use the sample data. So I now know I have 0.84 is equal to, I'm still trying to find that number. What number do I use for this? See, I have to go back. The mu of the population is normally the same as the mu of my sample means. The mu of the means. So I know I'm going to subtract 4. And then this is what?
0.3.
0.3. How'd you get that, Rachel?
Because it's the standard deviation of the sample.
Population.
Whatever.
Is the sample deviation of the population
Over.
divided by the square root of
N.
n, which is the
Which is sample space.
sample size.
Sample size.
Sample space, sample size, same thing.
Yes. Well,
Standard
For now.
error.
For
in
now.
this particular case, when we're talking about probability, sometimes we talk about the sample space as being all our possible outcomes.
Mm,
That is also known as a standard error, correct?
That is also known as a standard error.
Which is 4.
I don't want you to because actually as we do more and more different things, there's going to be, for everything that we do, we have its own particular way of calculating standard error. So we will be doing, depending on what we're doing, we will calculate the number that goes here in different ways. That's why I say we always divide by some sort of standard deviation. So in this case, I get 0.84 is equal to my missing number minus 4 divided by 0.3. And then I have to do a little bit of arithmetic, so I multiply everything by 0.3. So 0.84 times 0.3 gives me 0.252 is equal to some number minus 4. And since I want to find the number, I'm going to add 4 to both sides. And what does this number represent?
X, the mean of X.
No, it's not a mean.
What's gonna be?
It's a time.
Fine. Oh, yeah. and
It's a time. So what does that mean? It means that
80%.
80% of the reviews take less than 4.252 hours. And if 80% take less, that means 20% take more. So we're just doing what we had been doing in reverse. We had been doing things, what is the probability that a review would take less than 3.5 hours? Those were the questions we were asking beforehand.
Mm-hmm.
Which is a little bit easier to do because we look up, we just do the same basic thing.
We just changed the, yeah.
Well, if I look at this same problem, my mu of x is equal to 4, which means my mu of x bar is equal to 4. My standard deviation of x was 1.2, so my standard deviation of x bar of the sample is 1.2 divided by
The square root
of n. So see, that means we have to know that the n is
16.
16. See, if we don't know the n, we get stuck. We can't go any farther. So now if I said, so now I want to know what is the probability that a review will take more than 3 hours and 45 minutes. So now we're just going to do it back the way we have been working with it. So in this particular case, we still have our z we need. What number goes here?
Okay, the x is the 3.45, right?
What number? Okay, what number goes here?
The mean.
The mean, which is 4. What number goes down here?
The 0.3 there.
1.2 divided by the square root of 16. And what number goes here?
The 3.45.
Close.
Really?
It's not 3.45.
More
Only to
than.
convert it into minutes.
This is 3 hours and 45 minutes.
3.75.
3.75.
Right.
Because it's 3 hours and 45 minutes. Or if I want to do that, 3 hours and 45 out of 60, because it takes 60 minutes to do an hour, which somebody sat there and said they could do that real quick in their heads, and said that that was,
Is that supposed to be 3 and not 4?
yes, it is supposed to be a 3 and not a 4. See, we can't work with mixed measures.
I see. Yeah. Got it.
and see, now we're finding the z-score, right? So when we do this, we get what? Negative 0.25 divided by 0.3, which, I can
What?
do that.
No?
What? Wait, I'm
Yeah.
confused.
Wouldn't
It
it
is.
be 0.25 divided by 0.3?
No, negative 0.25.
3.75 minus 4 is going to be a negative
Got it.
number.
Negative 0.83.
8.3333333.
Yeah, 3B.
Yeah.
If it's a repetitive, you want
When we're dealing with z-scores, you have to go at least how many places?
Oh,
4.
2.
2.
No, I said 4 too. Oh yeah, I guess
Because
so.
see, now when I go back to my z table, I have to find 0.83. So when I go back to my z table,
20.33.
I go 0.83, which is right here.
Is that Bill? Where is that? 0.2033.
0.2033. See, when my z values on my z table only go 2 decimal places. So I have to round the 2 decimal places on this z table. If I had a more accurate z table, we would use more accurate values.
So that 0.2033 is the
20.
z score?
No, that's the
No.
probability.
That's the probability. So but the z score is the negative 0.83, right?
What was that, 233? I don't know.
2033. 2033.
Now, what does that represent?
The 20.
The
0.33%
20%.
of the something, something.
Hours.
Take
Right?
more than 3 hours and 45 minutes.
20%.
That represents this. The area that's in the area to the left. So this is the area to the left, 0.2033. What was my question?
What is the probability the review will take more than 3 hours and 45 minutes?
So my question was, what is the probability that the review will be greater than 3.75 hours?
79.67%.
How'd you get that?
1 minus that.
Okay, see, remember, the probability we looked up in the table is the probability to the left. So what we were able to find is the probability that it took less than 3.75 hours. So the probability that it took more is 1 minus 0.2033.
How to get 1?
Because remember, the area under the curve is 1. So if I know that the area to the left is remember we were looking those up and doing that with the z table. We were calculating probabilities. And remember I said we were going to be doing this over and over and over again. This is where these start to come in. I'm talking about how we work with samples and how we make some different thoughts about that. So let me see, 1 minus 0.2033 is 0.7967. So what am I going to state?
Probability is.
Probability
Review take.
of the review more than 3 hours, 45 minutes is 79.679%.
I am probably going to do things in a single unit. Even if I give you information in 3 hours and 45 minutes, it's legitimate and proper to change that to 3.75 hours.
Well, the 45 is 7.
So we're using the central limit theorem to take information about what we know about populations and what we're looking at with samples to figure out what the probability of something happening. If I have to do this every week or every month, I have to review 16 people. I can expect about 80% of the time that it will take me more than 3 hours and 45 minutes.
So do you really want to use that time?
Let's make it just a little bit harder.
We have 3 minutes left.
Good, but
No, because I have to go at 8 o'clock. Well, I don't wanna miss anything.
Oh, no.
Why you gotta do this?
Well, this is what managers have to do. What is the probability that it's going to take this amount of time? They have to be able to manage their time, right? So they have to be able to think about it. What is the probability that one will take me 5 hours? What is the probability that a review will only take me 2 hours? They have to be able to calculate these to be able to manage their time. Because if they have to do 16 reviews each month, and they take on average 4 hours, that means they have to spend 64 hours a month doing reviews.
So it's and.
We've done this problem, I'm not gonna do it. All we gotta do is look at this problem, is now I need to be able to work between two different areas. So if I'm looking at my standard curve, or my normal probability, I wanna be between 4.25 and 3.75. So I have to be able to calculate the z-scores that go here, and then be able to look those both up and do the subtraction to find the area that's
In between.
in between. We did that already.
I don't remember.
Yes.
I don't
you
remember.
subtract the probability.
I did, I gave you a bunch of problems on Lima to do that.
I know, and they didn't stick.
So all you're doing is subtracting the amount that you get at the end, your percentage.
Because the first time when I look up to 4.25, I'm finding everything to the
Left.
left, but I don't want this. So I have to subtract everything to the left of that side so that I'm only left with what's in the middle.
Okay, so. Let me think.
Now,
Wait.
I didn't quite get to it. I'm going to give you a formula because they're going to ask you some of these looking at some things, and I put it on the homework.
Okay.
I'm going to ask you some things about like the summation. Like I'm doing 16 samples or 16 reviews, and I want to know about how much time it's going to take me. So how would I calculate the summation of x, or the summation of x bar?
Count.
What am I going to do with the count?
1 is 0.
No, close. How do we calculate a mean?
Take it out and divide them, some divide.
We add them all up.
Some divided by how much there are.
Yeah, so if I want to do that, I'm going to add up all the x bars and divide it by n.
Now, don't that look a little weird?
Why it does it look a little weird?
Because, I'm probably wrong, but
Wouldn't that be the mean?
it's the same thing.
Wouldn't it be the mean? Isn't that the mean? Because by dividing the sum by the count, you get a mean. But that's already a mean, isn't it?
Well, see, that's because you're misreading what the x bar is. Remember, when we talk about this, if I wanted to calculate, okay, you're right. Hold on. If I wanted to
Thank you.
calculate
Thank you,
the sample mean,
yes.
Yeah.
it's the summation of all the means of all the samples multiplied by the number in the sample. So if I want to get this number, what am I going to do?
You add up all your sample.
Sample mean.
How am I going to find this number?
You add up all the sample mean divided by the count.
Yeah, but I don't have all the sample means.
Pray to God, you can do that. I don't know.
How can I find this number?
Did you say it already?
Yeah, we've done it several
Oh,
different
shoot.
times.